Alright everybody, how you doing today? We're going to do a little review of chapter 11. These are all the topics in chapter 11, corresponding parts, transformations, reflections, rotations, similar shapes, dilations, and perimeter and area of similar shapes. Now, before we left, we talked about corresponding parts, transformations, and reflections. We spent a day on rotations. We're not going to be very good at those. Similar shapes is something we've done a few times this year. Dilations is an easy concept I'm going to try to make you understand here in the next few minutes. And we're going to totally skip this one because this is actually in your 10th grade geometry book. I teach it to my geometry kids, so you're going to get it again then. Today on this first video, we're going to concentrate on corresponding parts, transformations, and a little bit about reflections and similar shapes. Then I'm going to put together a second video later to bring in a little bit more understanding about dilations. Alright, so let's get started here. Corresponding parts, that's how we started this chapter. And this was the Justin Verlander example, the hat to the hat and the nose to the nose. Now remember, when they tell you that triangle ABC is congruent to triangle DEF, they got to put the letters in order that they match up. So they're telling you that this angle A right here matches up with angle D right here. First letter, first letter. So angle A is the same as angle D, angle B is the same as angle E, and C is the same as angle F. Those are the corresponding parts. Same is true about the sides. This side right here, AB, is the same or congruent, that's the symbol for congruent, as this side, DE. Those are corresponding parts. First and second letter, they have to match up. We're going to use this same idea with similar shapes down here. Congruent means these two shapes are exactly the same size and shape. When we get down here to similar, it means you might have something like that, where this triangle is that triangle, but they shrunk it down or they enlarged it, which has to do with dilations as well. Those two kind of go together. So, we're going to do some of this stuff here today. Now a transformation, that's a slide. And that would be like this shape right here went over 2 to the right and down 3. We're going to do that here in a second as well. So let's get started with a little review. Alright, first of all, get your coordinate plane. This is the first quadrant, quadrant 2, quadrant 3, quadrant 4. I'm going to give you a little test on Tuesday for you guys to try. One of the questions or two of the questions might have to do with quadrants. Now, a slide. We're going to take this triangle, if we want to slide it, like up 2 and 3 to the left, that means you take this point and you go up 2 and 3 to the left, and it would end up right here. And that would be your C prime. Then you take this one, you go up 2 and 3 to the left, and that would be your B prime. And you do the same with this one, you go up 2 and 3 to the left, and that would be not a great drawing, but that would be your translation or your slide. Now, how do you show that? Mathematically, we took this A, which is 3, 2, and we moved it up 2 and 3 to the left. Well, 3 to the left is an X movement, that's minus 3. We went up 2. To go up 2, that's a Y movement where you added 2. So you might see a test question like that that says, how did you get this shape when you started with this shape? And you got to look at that coordinate 3 and say, well, they went up 2. So that means it went Y plus 2. And they moved it 3 to the left, so that means it's X minus 3. So you might have to figure out how they moved that shape. So those are slides. You got really good at those, and then we took, obviously this 2-week break. The next thing we talked about was reflections. A reflection is a flip, when it flips over. So if we take this shape and reflect it over the x-axis, remember, when you reflect over the x-axis, then you have to change the y-coordinate. Alright, so if I'm going to take this point 7, 2 and reflect it over here, I change the y coordinate to its opposite, a negative 2. I still go over 7, but I'm going to go down a negative 2. I'm still going to go over 7 here, but now instead of going up 5, I'm going down 5. And this point 3, 2 becomes 3, negative 2, because I'm changing that coordinate. And that would be B prime if we pretend we didn't do that one. And this would be C prime, and this would be A prime. A reflection is a flip. Remember, they got to be equal distance and 90 degrees. This reflecting line right here, there's our 90-degree angle, and there's a distance of 2 above and a distance of 2 below the line. It's a flip that's equal distance and 90 degrees. So you have slides where you notice the things A is pointing to the left. A slide moves all the way around the screen, but it never turns, twists, or flips. A reflection is definitely a flip. You're going to have a test question where you're going to show you this picture and this picture and ask you if that's a translation or if it's a rotation or if it's reflection. Well, you got to notice that it's just sliding around. They might give you this picture and this picture, and you got to notice that that is a flip, which makes it a reflection. One of your quiz questions that we had before we left, they started with this shape, and then they asked you, how did this shape start here and end up maybe over here? That's it, 1, 2, 3, 4. Okay, got that right. And what they're asking you is, what 2 moves did they make? Well, this would be 2 moves. You'd have to first recognize that they flipped it. So that would be reflected over the x-axis, and then this point went up 2 and over 6, whatever it is, and you have to say then they translated it up 2 and 6 to the left, up 2 and 6 to the left. So it's just 2 moves. Those are a little bit harder. We just didn't have a lot of time to get to those. I think you have 1 of those, 2 of those maybe on practice test there on Tuesday. It's multiple choice, so you'll be able to look at what they put down there and you might be able to figure it out. But it's just a good question. The hard ones is if they put the rotation in there, because we're not really good at a rotation. But that's a review of your translations and your reflections. What happens when you flip something over the y-axis? You reflect over the y-axis, the opposite coordinate changes. So the x-coordinate changes, so we've got to change the x. So if we go back to our original blue shape here, let me just concentrate on this for a second. If I want to reflect that over the y-axis, this is your y-axis up and down. You're going to reflect it over there, change the other coordinate. So since I'm going over the y-axis, change the x-coordinate, make that a -3, +2. So I go over a -3, +2. Change that to a -7 and keep the +5. So you go over here, -7, +5. Change that to a -7, keep that the same, 2. So you go over a -7 and 2. And this would be your B prime, this would be your A prime, that would be your C prime. So reflections, flip, and your translations, slide. Alright, those are the first 2 things I wanted to kind of review with you. Remember, x-axis, change the y-coordinate, y-axis, change the x-coordinate. Alright, so we did corresponding parts, we did transformations, we just kind of did a quick review of reflections. Let's talk about similar shapes. Alright, similar shapes. I didn't do a great job at drawing these, but a similar shape, that's the symbol for similar. It does not have the equal to sign in it because they're not the exact same shape. This one is smaller than that one. It's the same triangle if I could draw. We just made it larger or smaller. It's like when you change the font in your paper that you turn into your language arts teacher. When you need to fill up a 2-page paper but you only wrote 1.5 pages, you increase the font size to make it bigger. Well, they increased the font size. It's still the same letter, it's just larger. So, similar shapes, they got to follow the same rules. If I tell you triangle ABC is similar to triangle DEF, they're telling you angle A and angle D are still the same size angles. The angles are the same. It's just the sides have changed. And then the second letter B and E match up. So that angle is the same as that angle. But the sides are proportional, and you know all about solving proportions. So they're going to give you 3 of the 4 numbers it takes to complete a proportion. You just got to set it up and solve. I typically always do little triangle over big. It's just kind of the way I always set things up when I teach this. It's just the easiest way to teach it. So I take a number from the little triangle, ABC, and I'm going to take the 6. And that side matches up with this side, 10. So I got 6 over 10. Then I take this number 8, and it corresponds hat to hat, nose to nose, with this one, 8 over x. And now you know how to solve a proportion. You cross multiply and divide. So I'm going to go 6 times x, and that equals 8 times 10. And then you divide by the 6 to get the variable x all by itself. And that's 20, so isn't there 3 times, that's 18. I think it's 13.3 repeating. And then that would be meters. So similar triangles, they're not the exact same thing, one's smaller or larger than the other. You got to set up a proportion, cross multiply and divide. Now, they kind of have an idea that you already know about similar figures. They know you already know about proportions, so now they've got to ask themselves, how can we make this harder for pre-algebra kids, because they want to be algebra students next year. Here's how they try to make it seem harder, but it's not harder, it's just wordy. Here's a very wordy question about my buddy Aiden. Alright, this is similar figures. Aiden stands in the shadow of a tree, so that the tip of his shadow matches the top of the tree's shadow. Aiden is 5 feet tall. His shadow is 8 feet long, and he is standing 15 feet from the tree. How tall is the tree? That's very wordy. The best thing you can do is draw a picture. And there's my picture. Not a great picture, but it's what I can do. So it told me Aiden is 5 feet tall, so I put Aiden's 5 feet tall. His shadow is 8 feet long. There's his shadow right there, 8 feet long. The other piece of information they gave me is that he is standing 15 feet from the tree. So here's the tree. He's 15 feet away from the tree. Now, it's hard to see here, but there are 2 triangles. There's Aiden, his shadow, and the sun. There's also the tree, its big shadow all the way to here, and the sun. Those are your similar triangles. It said that the tip of his shadow matched up with the tip of the tree's shadow. So he just kept walking away from the tree until he figured out that his shadow was right at the very end of that shadow. That's how you can measure how tall this tree is in case you want to chop it down. So you still got little over big. I took Aiden from the little triangle, is 5 feet tall. That matches with that height of the tree, so I'm going to put that as T. Aiden's shadow is 8 feet long. And then this shadow, this is the tricky part, the shadow is not 15, it's not 8, it's both of those. He's standing 15 feet from the tree, and then his shadow is another 8 feet long. That means that shadow is 15 plus 8, that's 23 feet. Now I cross multiply, 8 times T is 8T, 5 times 23 is 115, and then you divide by 8, cancel, get the variable by itself, and that goes in there 1 time, 14, let's see, that would have been 35, 32, and 3/8, and the $1.25 rule, 3/8 would be 375, and those are feet. That's a little review of the shadow question. There are 2 triangles, there's still 3 numbers, and you're doing a proportion, which means you got 3 out of the 4 spots. Put them in there, cross multiply and divide. Make sure your answer makes sense. If the tree, if you did this wrong, the tree came out to be 6 feet tall, well, you probably did something wrong. So you got to put the numbers in different spots. All right, that's your first video for review. We got another one coming your way in a few minutes, but this is the first half of the chapter. We'll get back to you in a few minutes with another one. Thanks for listening. See you soon.